You know the feeling, your CI pipeline is running perfectly. Green checks across the board until one single CAPTCHA completely blocks every end-to-end test. Welcome to this explainer. Today, we're tackling a universal developer pain point. It's an incredibly common roadblock in automated testing, but by the end of this, we're going to fix it for good.
Because, really, there's a fundamental conflict here. It's almost a paradox, right? CI/CD pipelines are explicitly designed to run with zero human involvement. But CAPTCHAs, they are literally built to require a human. So when your automated test suite hits a CAPTCHA-protected login or maybe a checkout flow, the whole thing crashes before it even reaches the result you're actually trying to verify. That's exactly why you need a clear automated strategy for handling CAPTCHAs in CI. The goal here isn't to manually solve these things on every run. No way. It's about seamlessly integrating a solving service into your pipeline in a way that's controlled, secure, and doesn't blow up your cloud budget.
So here's our practical checklist to get this done. We'll break it down into 5 quick phases: strategy and secrets, helpers and environment, success metrics and timeouts, cost control and artifacts, and finally, common mistakes and a quick FAQ. Let's jump right into section 1, strategy and secrets. This is all about your high-level approach. First up, you've got to decide when these tests should actually run. Listen, you absolutely do not need live CAPTCHA solving on every single test run. Think about it. Running these on everyday pull requests is just going to massively slow down your pipeline velocity. Plus, it's going to needlessly inflate your bills. A way better approach? Only run them during critical milestones. We're talking merges to the main branch, staging deployments, nightly builds, release checks, or manual test runs. For your normal PRs, just use a skip flag, something like a skip CAPTCHA tests environment variable to bypass them entirely, unless the developer is explicitly changing that protected flow. Now moving on to the second item on our checklist, and this is an absolute non-negotiable rule. Never, ever hard-code your CAPTCHA AI API key inside your test files, your scripts, or your CI config. You've got to store that key securely using the secret management system already built into your CI platform. Whether that's GitHub secrets, GitLab CI variables, Jenkins credentials, whatever you use. Your test helper should only pull that API key directly from the environment. And if it can't find the key, the test needs to be programmed to either fail clearly right then and there or skip safely. Okay, section 2, helpers and environment. Time to lay down the execution foundation. Third on our list is creating a reusable CAPTCHA test helper, instead of copy-pasting your solving logic across dozens of test files, which is a total maintenance nightmare. Centralize these 4 steps into a single clean helper function. This one helper should read the API key, handle the submit request, manage the polling loop to check for the solved token, and take care of timeouts and error handling. Doing this keeps your test suite infinitely cleaner. Plus, a solid helper will support whatever CAPTCHA types you're actually throwing at it, like reCAPTCHA version 2 or Cloudflare Turnstile. Fourth, let's talk about stable browser settings in CI. We have all been victims of the dreaded works on my machine phenomenon, right? Where a test passes flawlessly on your laptop but mysteriously fails the second it hits GitHub Actions or Jenkins. Well, often the real culprit is just the browser environment setup, not the CAPTCHA at all. If you're using headless Chrome, you absolutely must use reliable CI flags. I'm talking about passing no sandbox, disabling shared memory usage, turning off the GPU, and setting a strict fixed window size. Oh, and always pin your browser or driver version. Seriously, if Chrome is crashing in CI, slapping these specific headless flags on there will usually fix it right up. Moving along to section 3, success metrics and timeouts. Let's figure out how to actually measure success. So step 5 is applying that solved token correctly. And the crucial point here is that simply receiving a CAPTCHA token does not mean your test actually passed. This is a massive trap developers fall into all the time. Getting the token is just step 1. That token still has to be inserted correctly into the hidden page field, and the protected form still needs to be submitted successfully. After solving it, your test has to verify the actual real-world result, like hitting a dashboard redirect, seeing a success message, or maybe even catching an expected error message. The real success metric isn't just token received. The real metric is, did the end-to-end test actually complete its intended workflow? 6 on the list, use realistic timeouts. Look, CI networks are notoriously slower than your high-speed local dev machine. A timeout that feels perfectly snappy on your laptop might just time out completely in an automated runner. The fix here is to separate your timeouts. Use one dedicated practical timeout parameter exclusively for the CAPTCHA solving step, and use a completely separate wait condition for your browser waits and page assertions. The solving process needs its own clock, while waiting for that redirect or success message gets another. Keeping these separated is an absolute game changer for debugging when things inevitably go wrong. Next up, Section 4.
cost control and artifacts. Let's talk about managing those budgets and logs.
7th on our master checklist is keeping your costs in check. CAPTCHA tests can get surprisingly expensive if you're just running them constantly without any oversight. You've got to use those skip flags we talked about earlier, strategically schedule your runs, and limit your test groups. But here is a brilliantly practical 3-step strategy you can implement. Just check your CAPTCHA AI balance before the test suite even spins up. If your balance is too low, skip the CAPTCHA test right then and there with a clear log message. Trust me, that's way better than letting the entire pipeline violently fail 20 minutes later just because you ran out of solving credits.
8th, make sure you're properly uploading reports and artifacts, because things will break. It's just a fact of life. And when they do, having a solid troubleshooting table like this one will save you hours. But to even diagnose the issue, the next developer who looks at the pipeline needs to understand why it failed. Was the API key missing? Did Chrome crash? Did the capture timeout? Or was the token just inserted wrong? Make absolutely sure you are generating test reports and uploading your logs and screenshots as CI artifacts. It makes tracking down these failures infinitely easier.
Finally, Section 5, Common Mistakes and FAQ. Let's cover the pitfalls and answer some questions.
All right, these are the classic do-nots that we've pulled together to save you a ton of head-scratching. Do not run live CAPTCHA tests on every single pull request unless it is absolutely necessary. Do not hard-code your API keys. Please do not treat token received as a passing test. Don't ignore the very real differences between your local browser and the CI browser behavior. Don't run massive parallel CAPTCHA tests without keeping a close eye on your costs. And lastly, whatever you do, don't leave vague failure logs that just say test failed. Give your future self some context.
Okay, let's hit a quick FAQ, because this is by far the most common question developers ask when they start setting this up. Should every single CI run solve CAPTCHAs? The definitive answer here is a hard no. You've got to be strategic to preserve your pipeline velocity and, of course, control those costs. In almost all cases, you only want to run these on main branch merges, staging builds, nightly schedules, or manual triggers. And like we said before, rely heavily on skip flags for your day-to-day pull requests.
Here's another really great question. Since modern test suites run concurrently, developers naturally wonder, can I run CAPTCHA tests in parallel, or is the solving service just going to bottleneck the whole process?
The answer is yes, absolutely. Each test execution gets its own unique CAPTCHA solve, and robust services like CAPTCHA II can easily handle concurrent requests without breaking a sweat. So yeah, it's fully supported. But, and there's always a but. Remember our previous warning? Watch those cost controls like a hawk when you start scaling up massive parallel executions.
And that brings us to the end of the checklist. I want you to take a hard look at your test coverage today and ask yourself this final question. Is your CI pipeline truly fully automated, or is a CAPTCHA secretly holding it back from achieving true end-to-end validation? If it is, well, you now have the exact blueprint to conquer those protected flows once and for all. Thanks for joining me on this explainer, and happy testing.